So the good news is it's actually not about technology. Some misconceptions about technology, which I hope to sort of demystify in the next half an hour. It's more about how technology is consumed in the industry, because it's fundamentally what's wrong with a lot of the construction industry. The industry is absolutely awash with buzzwords at the moment. I've heard a lot of them used here today. Unfortunately, what a lot of these things produce is buildings that don't do anything, don't really have any features, and are incredibly difficult to maintain and operate. There's a lot of blue sky thinking around a lot of these words. I see them in hundreds and hundreds of pages of documentation, but it's getting past that point of how you build one of those things. How do you build an IoT? And that's where the conversation stops with most people. These never translate into truly smart or intelligent buildings. Now, I appreciate smart building is one of the words I've got up there that I criticize as a buzzword, but for the sake of consistency, we'll refer to smart buildings today. So this is talking about smart buildings, how you really create one, and what's wrong with the industry. It's not technology that's at fault here. It's the way we consume it as an industry, how it's applied to problems, and the manner that that's done. Systems for all of these types of buzzwords tend to be added in a disparate way, one by one, and inexpensive and clunky manner, which doesn't really increase efficiency. It reduces efficiency and functionality overall in the end experience for the clients, the customers, and FM teams. It's a very difficult thing to deal with. So 10 years ago, the big buzzword was green technology. Everybody jumped on it, used it in all sorts of marketing. Unfortunately, 10 years later, we've ended up with a lot of things that don't really do what we were told they do, things that take more energy to build than they actually ever return, but that's a topic for another presentation. But what we're trying to do is stop smart buildings or intelligent buildings becoming the same victim in 10 years' time, where the experience that everybody's had of technology is it's such an unreliable and difficult thing to use. That we just don't use it anymore, because we're right on the cusp of it at the moment. There's a traditional way of designing buildings, unfortunately, in the construction industry that hasn't changed for 20, 30 years. It's very much this, the client's vision at the beginning. They have an idea of what they want to build. It might be a commercial office building. Any ideas or aspirations that they have for what that facility might do, how it might run, what sort of things they want to focus on, very quickly gets lost. We tend to have a project manager or a principal consultant that got mentioned in the last panel debate, that the contracts get awarded to and then get immediately split apart into 10 different design packages. It will go to a mechanical, an electrical, a separate IT guy at the end, and unfortunately, through this process, all of this vision and alignment and common connectivity or features gets lost as it goes all the way through the process. And what happens is there tends to be an attempt at the end to then stitch all this together again. So the market is full of integrators at the moment, which will sell you a lovely lump of software and networking to try and stitch all these systems back together afterwards. This is really what smart building companies are selling themselves at the moment, but really they sit down here, this bit at the bottom, to try and bring it all back together. But this is a very disparate approach, and it doesn't really produce what we can really call a smart building. And it's really that client vision of what they want that to do that it gets completely lost and diluted. And I think as facilities management teams, you then experience the output of that in trying to manage what that is at the output as well. As a model, in terms of systems, this is exactly what happens. So I've tried to represent here from these individual systems all getting designed in their own. So they're all different consultants that would go off and do these in a traditional manner. Your mechanicals, your electricals, and everybody else, there'll be separate system head ends for each one of these. There'll be different languages that they're built on, different communication protocols, different gateways and interfaces. It's all generally unreliable stuff. There's then an attempt to add this fancy latest gadget or latest app that brings it all together that looks very shiny on the front end. And then the IT entity is always a separate entity. It's never, the IT element is never involved in the early stages of design, which is a fundamental mistake in applying technology to this industry. The bit that you don't see in this traditional way of building a smart building is all these bits. And as facilities management, this probably means a lot of sense. We see this again and again because of all these different systems, all have different languages, They all were designed in isolation. They were never designed to work together to do a common thing or to sit on a common platform. You have to have changes of language, gateways, interfaces. So we call this an interfaced building rather than a smart building. Now, when it comes to management of this, because facilities management were never designed in client visioning, the design process right from the beginning, what gets spat out the back end, you get handed over a building that's full of things like this. So there might be a lovely colourful app at the front end that Mr. Client who signed the check has got and he thinks it's great, but actually the user experience is the thing where it falls down, because a lot of these things will break down. They need to be maintained, they need a lot of adjustments, and your facilities management team probably aren't set up to deal with this horrific thing that this integrator has produced. So when the £100 gateway that changes the languages between two of the systems breaks down and Dave the plumber goes to fix it, he won't know what to do with it, and he'll end up bypassing the system, putting it into manual, and everything will go back to in-hand mode. And the problem is that's where technology gets its perception in the industry. As soon as I mention technology to any clients, they sit back, fold their arms, sigh and say, well, this sounds expensive. And this is exactly the reason why, because of how we're consuming this at the moment. That's the experience that they have, that it is unreliable, there's lots of parts, I'm constantly trying to make it work, and eventually I give up, put it in manual. So this perception is a real problem, but it's nothing to do with the technology. The technology is the easy bit, it's just how it's applied and who owns that. So the client's vision, this is something that every interaction between the user and the building, it needs to be carefully considered in every part of the design, across every single discipline in that building. We use this process called user story mapping, and it captures in the very, very early stages, before any consultants are really involved, pre-stage one on Reba, what that client wants to have that building to do, its features, their wants and needs, and it starts to define the technology and the system parts. Now, although I say technology, it's not really about the latest gadget or app. Technology could be the right fan call unit for the space because of how it communicates and what it does relative to what that client wanted from the space. So we use this process to capture really what that client wants, but also to play back to them in a palatable way, because the problem with technology as well is there's a lot of misunderstanding. Non-technical CEOs of large developers, they don't want to know about communication protocols and gateways, they just want to know what it does. And that's the problem, there's nobody owns that message for them. So this is where this all starts, really capturing this for them, taking that uncertainty and pressure away from them, what that building's going to do, and where it exposes systems, it drives the technology, the things we're going to select. This process also highlights privacy concerns. So if there's going to be any information exposed in any part of the system at any time, so with GDPR coming in, this is a really important aspect of this process. It helps them understand where their business will be at risk and how they need to quantify and control that. Backbone tasks, it plays out as a story. So we create personas for each type of person that will use, operate, and work in that building every day. So facilities management are part of that as well. We have facilities management involved from day one. So they're almost architecting and creating what that space will do, how it will do it, which bits it's going to use, and they're part of that iterative design all the way through, right through to operation as well. We look to support them through the operation process as well. So the client understands this palatable way what it is they get out the back end. This is some actual examples from some projects that we're working on at the moment of this process playing out in real life. As you can see, it gets pretty detailed. There's several weeks locked away in a room where we generate all this stuff, and then it gets played back to the client in this palatable way, and they then understand what it is they're getting, because it's just features. It's not blue sky thinking and aspirations, things like workspace transformation, whatever one of those is. They're actually told this space now does this, this, and this for this person who works there. There's a number of options from the must, should, could, and won't, so they know exactly where they are with the baseline, what they're going to get from all the bits of technology we've picked, and then overall as one holistic package, what they get out the back end of it. So, how do we do this? We've coined this phrase MSA, which is Master System Architect. It's something that we felt was missing from the industry. We stand really, as I said before, in user story mapping, owning that client's vision, and it's a story in effect. As that drives the technology at the back end, you must have an understanding of every discipline within a building and how the selection of one discipline, system, and piece of system affects another. So you can't select a piece of equipment, a data bit of IT equipment without understanding electrically what that does to the rest of the building and what it does to mechanical heat loads. That's a very basic example, but the same is with technology. You can't just add systems upon systems to get features, because you end up with that disparate model of many parts, which is not a very efficient design. The way we're able to do this is because of our understanding of IT, traditional IT and technology, and also the construction industry. As ISG, we build buildings, we know how to build them properly, data centers and all sorts of facilities, but we know how to do it properly. So having that understanding of both sides of the industry allows us to sit in this position across all these disciplines, owning the client's vision, the staff and facilities management, what they need from those spaces, involving them in the process, all of the specialists. You still have the integrator as part of that process, but they are writing software under the direction of us, and they sit amongst all the other supply chain, and we all work together to create one holistic MSA-driven solution. You can't apply technology for technology's sake. It must be carefully selected around what that client wants from their user story mapping, what that vision is, selecting the right parts, and having as few as possible. So picking one piece of technology that we might be able to drive 10 different functions out of. So something that knows where people are, we can use that for security, for evacuation, for hot desk bookings, all sorts of things you can do with it. So the software integrator would be writing that software as we build those ideas up. Because we're all working together, we've got very, very few parts, and it's a very streamlined design process. The relationships that we have with our supply chain is also absolutely critical to this process. So things that are available off the shelf at the moment in terms of technology, they're serving a very slow organic growth market. So you can buy LED lighting now, but the opportunity for it is very, very small, because it's usually awarded under an M&E package. There'll be an electrical side to that package, then a lighting designer, and there'll be some graduate lighting engineer at the end. And to them, they can get a £10 Argus light fitting, or they can spend £200 on an LED fitting. So that market is very, very small, because they'll always go with the cheapest. Because unfortunately, we have something called value engineering, which really, in our opinion, shouldn't exist. You should just design it right in the first place. You should never be able to value engineer things out. So the opportunity that we create, because we can then embed other sensors in that LED lighting to do other things, but it still costs relatively the same, then it becomes far more valuable. That market has changed. And that drives true innovation, because innovation, unfortunately, is being diluted and lost at the moment in the industry. We always look to build around this single unified communication platform, which at the moment, smart building aspirations, people try to use BMS networks, which BMS networks are full of security issues. There's a lot of exposure points. They're very easy to hack. There's a misunderstanding of this in the industry. And we find a lot of our clients, their IT people will look at those systems, don't really understand the type of protocols they're using, and not understand the security risks that go with them. BMS networks are not designed to be the platforms of smart buildings. They're designed to be BMS systems. BMS systems don't make smart buildings. You need to have this common communication platform. IP, IT network, if you like, is absolutely ideal for this. There's a lot of PoE advances coming at the moment where you power devices directly from data switches. We use this as much as we can in our designs, because you can apply enterprise level security to everything that's on that network. And where you replace this power over Ethernet power, it takes away the lighting power, for instance, so you no longer have traditional electrical contractor wiring up a light. It's now got a data connection on it. But because we've got that data connection, you power it from it as well, and we can embed other sensors to do other things within that light. So you've only got one cable that's doing 10 different systems, and you don't need separate power infrastructure. It all comes to the light. So this really drives innovation, this approach, and we're able to leverage new technology with our supply chains. It's one of the most difficult conversations to have is around supply chain. Customers and clients are relatively easy, because for them this all makes sense. It's of great value to people who make things. So somebody who makes a BMS system, to go and sit with them and say, this is why you're doing it wrong, here's how to do it right, we'd like to work with you. It's about 80% successful, but we need those relationships to be able to leverage this new technology and really give it value, and really grow true innovation, and give clients something that is exactly what it should be. So around this communication platform, it all needs to start with the client, from their owning their story from the beginning of what their visions are. We look to stay with that process right through to operation. So when we do go to operate the building, facilities management know what they're going to get. They were part of the crafting process all the way through, and they know every system because they sat in this design consortium. This approach, it's universal to sectors. We've done this in data centers, hospitals, oil and gas facilities, as well as commercial buildings. It's just about designing properly, really. It's not about technology. It's having these design committees rather than 10 different disparate consultants. We all sit together, we work together as one design consortium and make decisions on, if there's several people around the table that have a similar bit of equipment, we look at, well, which piece of equipment will give us all those features. We can adapt it and change it so it will work properly on the common platform. We write the software around it and it does the thing that the client wants. So that's where we sit as this master system architect across all of these disciplines. This model sort of shows the two different approaches. Where on the left-hand side, where the traditional route, the client's vision goes into design, into these multiple disparate parts, and when the building comes together, it's integrated together, which we call an interface building. And what you end up with in terms of facilities management is something at the bottom left here, which is actually lots and lots of still disparate parts with this extra system almost clamped on top as the integration layer, which is just something else that you have to deal with to maintain, rather than actually adding any value to what you're doing. On the right, this is our approach, because we have these design consortiums together as the MSA. Through the design process, everybody's worked together. FM, client, users, people who work, manage and own that building are all involved in the design process. And what you get at the end is a building that is just one entity. How they run it, operate it, live in it, everything is exactly as they expect it to be, because they were involved right from the beginning. You can only achieve this true, smart or intelligent building with having all of those parties involved all the way through. This change in design approach of having everybody work together changes what you get at the end as FM. And that's really the only way to do it. I think it got touched on a few times in the previous panel, but this is only really the way you can do it. You have to have all the disciplines together to be able to get something that comes out as one package in terms of maintenance as well. There's also a bit of a misconception in the industry that to use technology, it's an investment, you must invest in technology and it's an add-on. Through this process with our clients, often it's been a rationalization process, so we usually get involved, not ideally at stage 4, but there's already 20 different developed packages from all the different disciplines. We've had to then sit with all of them, rationalize and use an IT budget to try and make it a smart building. So we take out the bits we think we don't need, get the client driven to get an understanding of what their vision is and how we're going to reshape those packages around their vision, pick our battles and only apply the right bits of the systems that we actually need to achieve the things that we want to. And throughout that process, we found that most of the time it comes out costing exactly the same. Sometimes it's been 10% cheaper. So to build an intelligent building doesn't cost any more money. If anything, it actually costs less. So everybody wins. The client gets something that they didn't know that they had a problem with in the first place. They get frustrated in the building that they're trying to maintain, but don't realize that it's actually their fault for not asking the questions in the very, very early days of the thing that they actually want. They've just always done the same thing for the last 20 years of, well, I appoint this project manager, I appoint this master consultant, and they just build me a building. And that's the problem. It's education. So this is where the journey starts. We sit and educate clients and help them understand, well, if you ask for something different at the front end, make sure somebody owns your problem all the way through. You'll get something different at the back end of it. And all of this stress, uncertainty that they're used to experiencing, and headaches from maintaining these facilities and all the money it costs to keep these things going, that gets taken away from them. So everybody wins. You get something that's cheaper. It now does a number of quantifiable features. They can actually mark it and hang their hat on, my building does this because I asked for these things to be done. Rather than we see a lot of very early stage blue sky thinking, hundreds of pages of buzzwords where it never turns into that facility. It's only ever the app that sits at the top that seems to have these features, but the bit that it falls down at is the user experience. When somebody actually comes to use that and a small part of that big jigsaw breaks down, the whole thing collapses and falls apart. But this is not the technology's fault. Again, it's how it's applied, who owns the problem, and how it's architected all the way through. But we're trying to, as part of this, change this perception of it being expensive and an add-on and difficult to maintain. It's the absolute opposite. Whenever we go to talk to clients, they get a little bit sort of overwhelmed when we talk about this approach, and they ask us to define what a smart building is. I've never seen anyone else really be able to actually define what one of them is. So we came up with this simplest form as a bit of a scale of how we see the industry as it sits at the moment. So although we use smart buildings, we see it quite far down the scale really. You will often see done buildings with disparate systems that were designed standalone, as the model showed before, hardwired together, some basic rules, behavior, some basic system integration. This is where the layer sits over the top. I only like to use the word integration when the two systems are truly built around each other. Connecting the two together with a bit of software is interfacing, as they say. So we find that most of the competition is somewhere around here. Even when we're told it's a smart building, we often benchmark and critique for clients against other buildings. It's nearly always down there. Really what we should be doing is having an intelligent building, and this is the phrase that we're trying to push more into the industry, is an actual intelligent building versus a smart building. And these are really all the different elements that go with that. Some buildings, we can only make them as smart as they can relative to our budget, but always they should be intelligent. There should be self-optimization, machine learning, adaptive technology, insights reporting, not just hoovering up data from systems and creating data lakes. People drown in data lakes, that's the problem, because no one knows what to do with it. Really, it should only be surfacing relevant data to relevant people at relevant times. And this is very much what we try to do here, not just connecting everything to everything for the sake of it, it's establishing this common platform of connectivity for all the systems that are then built around that platform, but only selecting the right parts for the right application. So you can only do this if you have the right design approach. If you have one system that's disparate and outside of this design approach, you go straight back down to standalone systems, and that's really where you sit. You're not ever going to create a smart building from that. There is also a misconception in the technology, that the more technology you apply, the smarter it gets, but I think we all know it's the complete opposite. It becomes harder to maintain, it's less intelligent, it does less things. There's a methodology, and it got touched on earlier in the panel, about how we approach our design. There's a principle behind all of it. In our personal lives, whether it's search engines or our smartphones that have all of these different systems and services brought together in one place, social media, networking, it's all the same principle in our personal lives about having it's the availability, the visibility and resiliency of information. It's having everything in one place at one time, all the time. But this isn't how we build buildings. We build buildings in 20 different places and then try and make it be in one place at one time. So why we run our personal lives in this way and don't roll it into our commercial space is beyond me. But I think it just comes down to education and understanding that there's a way to do that, and it isn't throwing more technology at it. But this is a principle behind everything that we do. It's our personal lives meeting commercial space, and how we do it. It's bringing that modern, hyper-connected digital world that we have in our pockets every day into our commercial spaces. We should be doing it exactly the same way. So what does this mean, the value for facilities management? I've touched on it a couple of times. It's about surfacing the relevant information to relevant people at relevant times. So I think the type of building that you're used to maintaining, it's probably got 10 different head ends with 3,500, 4,000 alarms on each, and nobody can work out a problem. You need to send lots of people. You send the BMS guy to look at the BMS, and he says, oh, it's something wrong with the SCADA system. The SCADA guy will say, no, it's got a network connection on the back, it's an IT problem. You call out the IT people. You've got these massive service costs and framework agreements, lots of disparate parts, and then if you've added a smart system on top, an app or an integration layer, you've then got another problem. And the problem is that all of those individual trades will blame that integrator because he's the easy target, because he's the IT guy. So really, we want to take all of that thinking, intelligence, predictive maintenance got touched on earlier. These are all things that can be easily achieved through this approach. So these are actually parts of a user story map from one of our clients, very early stages. I can't really show you any of the latest stuff because it's very detailed, but this is how we started the journey with them. We'd done the post-it note exercise and sort of gave them some ideas of the things we could do, and this is how it started to play out for them. So one of the things that they wanted was people movement and behavior versus energy usage optimization, some intelligence being applied to that to make suggestions of changes they can make. So the only way we were able to do that is that all of the systems in the building, all of the building M&E systems are all completely re-architected around this approach. So we changed the controllers, how they communicate, what they communicate. It's all IP based, powered from the data network, which it wasn't before. So having all those eyes and ears around the space allows us to surface certain information to them. So there's a load of intelligence applied to this. Part of the workflow for up there at the top, it's about crowdsource fault identification. So because of this digital ecosystem that we have, when people are in this building, they can take a picture of a problem. There's people tracking, there's geolocation. It sends that event to somebody who's on duty in FM. So if it's a water leak, if a plumber is on duty, it gets sent to him with a picture, location, this person's reported, there's a water leak on the floor, so a ticket is raised in their system and it goes to the right people and they can go and fix it. And we're finding that most of the problems they normally have to deal with in the maintenance of a building are going to be dealt with this intelligent layer. And what this impacts on downstream is all of the framework agreements they would have traditionally had with their FM companies. So the BMS provider, the data network provider, everybody else, all their packages by design were all shrunk down to about half the size. So in terms of the value that they would have normally pinned on that agreement, and they used to just churning out the same framework agreement and blaming each other, that has been rationalized. They've been forced to re-engineer that and really think about what they're doing. So not only from design and the systems that they created with us, now how they're going to run and operate and maintain those. So we sit at the top of that still, as the master system architect, the software layer and the people who work at that level, they're able to sort out most of the problems of the building because everything is so well connected. Most things get surfaced to the right people before it even becomes a problem you need to react to. So we have predictive maintenance is a big drive in this building. We have a lot of information in BIM. So BIM, there's attempts to create that as a sort of CAFM management tool. But again, that's evolving in a silo on its own, and the stuff that we're seeing coming out, it's very sort of isolated and disparate. The approach that we took here was to actually integrate BIM as a smart building system as part of the connected real estate that's around it. So been able to know from a fan coil unit when it needs to be serviced, when it needs a fan filter changed, these sorts of things. We're able to connect these two things together and have a predictive maintenance regime where it'll actually reorder the parts from the manufacturer's website, it'll bring them to the site, and it'll put an event in the FM's diary. Tomorrow you're going to go and fix this fan coil unit, it needs its belt and its fan changed, and here's the parts already arrived from the manufacturer. That information is there in BIM, it's just joining the two together, which we're able to do as part of embedding it into the smart digital ecosystem. It will also take them to where that asset is, because we've got this internal tracking that's there for different purposes, but we're able to leverage that as an extra benefit for FM as well. It will take them to the asset, and actually, if they need information about that asset, if it exists in BIM, so if there's a PDF of how to change that filter, it's already available through the building's app as well, because that information's being pushed from BIM, because it's to a relevant person, rather than them having to go to a BMS head end that says something's wrong somewhere in the system, and you find out that the fan's blocked because the filter didn't get changed, because nobody picked up that it needs its maintenance done, etc., etc. It's reactive maintenance, rather than we can cut all that pain out by doing something predictive. So these types of workflows came off the back of this early aspiration with this FM team, and we've grown all these workflows and played out each type of person that will work in that building, and actually brought to them what's relevant, because they have maintenance visitors as well. How do we deal with them in terms of the building? How do we give them the right information as well? Even security issues and all sorts. But we've managed to architect that all using our systems. So none of this was aspirational thinking. This was a product of a lot of the technical work that we had done. This was a stage 4 technical rehash. We created this ecosystem, and then this was then presented to them in this way, which I think you can agree is a lot more easy to understand. And there's a 3,000-page BMS document, there's a 3,000-page SCADA document, which nobody wants to trawl through. It doesn't really mean anything. And actually, it doesn't do anything. It just tells you alarms that then you need to go and try and sort out what's wrong with the building. Applying this intelligence, though, it absolutely takes a lot of that pressure, time, diagnosis away from the FM teams and the client, and it's creating a streamlined model for maintenance as well. So the technology to do this, it's not something new. There isn't future smart offices. The technology has been around for 10 years. I've spent the last 10 years of my life overseas building buildings in this way, just because of how the construction industry is in those countries. They don't have a traditional way of doing things, and they don't have hairy-ass builders, as you say. It's very much emerging markets. They've got a big box of money, and they want somebody to build them something that does X, Y, and Z. They'll give it to one person, expect them to go and build it. We don't do that in this country, and that's where really all of these problems that we see at the back end in terms of facilities management starts. But really it starts for us educating that client, owning that process as the master system architect all the way through, and then what you get at the back end is something that is streamlined and easy to maintain. So technology, it has already changed. It's not something that's in the future. We just haven't changed the way that we design and run buildings yet. That's something that we're trying to make sure happens all the way through. So what we get as a product at the end is completely different. Has anybody got any questions or wants to pick brains? Yeah.
Jason Rutherford on ISG, Hairy Arse Builder.
Nice to meet you.
Data protection and security of buildings is really important at the moment. I was really interested when you said that BMS systems have been hacked. Have you got any examples of that?
Yeah, so easiest way to answer that, if you watch Mr. Robot on Amazon Prime, it's a fantastic example of exactly how to hack BMS systems. They're incredibly vulnerable. So what it comes down to is communication protocols. There's a lot of BMS systems use serial communication that was developed before I was born. So anything that sits on two types of communication protocol that are RS-232 or RS-485. So Modbus, BACnet, serial comms, LONWorks, that sort of thing. Everybody hears of these in that part of the industry, but what they are, to hack it, you can't, because it's from the 80s, you can't apply any sort of encryption or security to it. It puts out a request for something to reply, and then when something replies, it just trusts that that's the thing that's replying. Now the problem with that is if you have some exposed cabling in the ceiling, it's only one pair of wires, and I've seen a live demo of this happen. If you put a pair of crocodile clips over that cable without even breaking the insulation, you can pretend to be anything on that network. So an example that's probably appropriate though is I was in China building a drugs research facility. A lot of money involved, and the competitor drugs manufacturer was next door. I can't name the names, but and when we had finished this building, I came in quite late to the process as a sort of ELV systems manager, and they had created this very complicated building management system because it was all drugs research, animal testing, that sort of thing. And what they had was they'd gone down a wireless route. Wireless is never a good idea with these sorts of systems. And what was happening is we found out that they were paying people locally to go and sit in our car park with big wideband antennas on the roof and try and hack wireless serial communication systems in the building. But what they were looking for is like wireless room temperature controllers and things like that. And we discovered later the reason being, because they were doing animal research in the building, they were trying to turn the temperature up in the laboratories, but make the head end report that the temperature was still the same. Because if you, in the drugs research with animals, if the temperature goes above or below by a couple of degrees, you've lost a year's worth of Ebola research. And that's what they were trying to do, was sabotage the research by hacking into the building across BMS serial communication. So that was one of the things that we highlighted even before that happened, that it's a security risk. So by design, there's a misunderstanding that anything with serial communication in it is very vulnerable. You either physically can hack it very easy with just a pair of clips on it, you can do it from DOS, it's really easy, or wirelessly, it's wide open. But for IT organizations within businesses, and we've had this with our own clients, they look at if it is a smart building and they've added a BMS network onto their IT network, they just see, well, there's an open sort of port that goes to the BMS network. We don't care what that does, the BMS guys look after that. But what they don't realize is it's a whole universe of open back doors for anybody to walk through. And that's where buildings get hacked. I was at annual hotel conference about 6 weeks ago, and there was a hacker there that had done exactly that to a hotel. It's BMS network, wide open, and he was able to control everybody else's room from exactly this approach. There were wireless controllers, just took the address of the room next door and was opening and closing their blinds, switching the lights on and off. It's the same problem, but that company had been through this security risk assessment process, and from their IT perspective, oh, well, it's fine, our IT network's completely bolted down and secure. But that very small opening that goes into the BMS network, that was all wide open, but they didn't have that understanding. So we've had to educate some of our clients' own information security people of, well, you do realise this is hugely dangerous and anybody can get in there, and they just don't know. So this role of the MSA is really important. This is this multidisciplinary understanding of, you might understand IT, but you don't know the things that you're connecting to it. If you don't understand those, then you can't really assess the security risk. So yeah, it is a big problem. Okay.